Now let us talk about graph, which is a very important topic as far as data structure is concerned. Let us introduce some definitions and examples. So what is a graph? This is a set of individuals and their pairwise relationship. Means consider these to be individuals and these two have some relationship in between. So this is a kind of graph. The individuals, these are called as nodes or vertices. And vertices, this is the plural of vertex. Some also call these as points, mostly by mathematicians. And the relationships, these are called edges. These are edges, which are also called as arc. If they are directed, means if they are directed, and sometimes also lines. Various things in the real world can be naturally and intuitively represented by graphs. For example, computer networks, social networks, any relationship, all those things can easily be represented. And if you go ahead, that means transportation network, or say two streets, how the edges shows how these two streets are related. Financial networks, supervision between branches, entities of government, the World Wide Web, hypertext, proximity and sports, you name it, and graph, wherever some relationship has to be established and some nodes are there, various nodes and their relationship, then graph will always be there. So one thing we need to keep in mind is that graph only capture pairwise relationship. Means these are two nodes, and pairwise relationship is what graph looks for. Let us think that suppose you are trying to model a set of people, that is nodes, whether they take classes together or not. Assume that we have A, B and C, right? You have 3A and B, C, and if you have an edge between all three pairs, means AB, BC and AC, that could mean that all three are in a class together, or that there are three different classes, one which A and B are taking, one which B and C are taking, and one which A and C are taking. So a graph does not actually tells you or distinguish between these two real world scenario, whether these three are in a similar class or these two or separately a couple has a different class. If you really want to model these kind of difference, then there are various approaches for this. First is you have called hypergraphs. Graphs to hypergraphs. Hypergraphs have hyperedges which may contain more than two nodes. So hypergraph can have it. And a hyperedge, that ABC which we just talked about, could capture all these three people. They are in the similar class together or not. And in most of the books and classes, these hypergraphs are usually not covered, because the graphs are, they are so enriched now, they are able to do a lot of work. So a different way could be to use our graph to completely different type of nodes, means people and classes, because if we want to model the difference, one is hypergraph, the other can be completely different type of nodes, like peoples and class. And then we can draw edge between a student node and a class node if the student is enrolled in the class. If we would not have any edge between people or between class, this will completely capture the scenario we are concerned in. For example, two different types of node with edge only between nodes of different type, these are called bipartite. Okay, so in order to talk about graphs, really we need to know some terminology and notation. So a set of all nodes is usually denoted by capital V, which is for vertices, and set of all edges by capital E, that is for this. These are for vertex, these are for edges, and the sizes are like this, V and E, and this is the representation of how to capture the size. This is N and M. So in talking about graphs, we use this N and M is quite standard sense. So please do not deviate from it. Various books have various terminology and notation. Graphs are denoted by V comma E, that is G is equal to V comma E. These vertices are often named as UVW, and edges are by E, E dash or F. Edges may be directed or undirected. This is directed, and direct means no direction. Undirected edges model relationships that are automatically reciprocated. For example, being friend or married, because if A is married to B, then this is known, or this is but natural, that if A is married to B, B will also be married to A. And two-way streets, for example. So these, we don't need to have a directed graph in this case. And directed edges, what do they do? They model relationships that are not necessarily reciprocated. For example, if A is a parent of B, B cannot be a parent of A. A is a supervisor of B, B cannot be a supervisor of A. So directed edges, they are also known as arcs. Directed edges are also known as arcs. So a graph which have all the edges as undirected, that graph is termed as undirected graph, and the similar graph, if all edges are directed, then they are termed as directed graph. And if we have directed as well as undirected in a same graph or in a single graph, we term that graph as a mixed graph. And we often draw the nodes as circles like this, or rectangles, but mostly nodes as circles, and edges just by straight line, or we can also draw as an arc. So when edges are directed, we use a arrow for the direction, and when there is an undirected edge, that is say between U and V, we call U and V are adjacent. Okay, if A and B have undirected edge, then A and B are neighbors. U and V are neighbors, and when they are related by direction, people usually avoid the term adjacent, just not to create any confusion. If an undirected graph means with no arrow, the degree of node V, say this is U, this is V, the degree of node V, which is written as degree of V, or say dig V, or sometimes just dV or d sub V, this is the number of edges that V is part of. The degree is actually the number of edges for which this V is one of the part, then this is called the degree. And in undirected graph, we usually distinguish between the out degree, that is the number of outgoing edges, which is denoted by out degree V, or d out V, or d plus V, which is the number of outgoing edges, and in degree, same because of number of incoming edges, this is denoted by in degree. In degree V, you can represent it through in degree V, or d in V, or dV. So when you do some basic computation, you perceive that a graph with some n nodes can have at most n square, that is n square or n minus 1 or n minus 1 by 2 edges. How? It depends on whether we allow a node to have an edges to itself or not, or the edges are whether the edges are directed or undirected. So undirected, directed, and to itself. All these three in variation we can have n square and n minus 1 and n minus 1 by 2 edges maximum. So one thing is very clear, and we need to be sure that it should not be order of n square or theta of n square. So we call a graph with order of n square edges as dense because this is the maximum possible, and the graph with much fewer than n square we call them as sparse. So dense and sparse. So what are paths in graph? This is a very important topic. This is actually a central concept which will actually allow us or enable us to model the graph. This is what we call as path. So it captures one ability to get from one node to another, not just only by one directed, but by following a sequence. Means if I can go from A and B, it is fine. Is it possible I can go from A to C and C to B? So this may be a path. So a formal definition of path is, it is a sequence of some nodes, say V1 to Vk, such that for each I, consider this to be some Vi in between, Vi. So for each I there is an edge from Vi to Vi plus 1, maybe directed or indirected. So path exactly captures our ability to traverse multiple edges in sequence. And we explicitly allow this case k equal to 1, that is a node by itself, which is also a path. Why do we do it? It helps us to avoid having to deal with specific cases in proofs while we are proving. So path may repeat the similar node or edge multiple times, and if you want to, or if you wish to rule it out, we can talk about simple path. A path is simple if it does not contain the similar node more than once. So if you have not more than once, then we say it as simple path. And what about cycle? Also some books have written it as circuit. So this is a path that starts and ends at the similar node. Starts and end at the similar node. So we say that two nodes U and V, they are connected if there is an undirected path between them, and the definition is true for directed graph also, but somewhat used seldom. So two nodes are connected if it is possible to get from one path to another or one place to another through a path. So one will have paths to another. And the undirected graph is called connected if every pair of vertices in the graph is connected, while a directed graph is considered to be strongly connected if every pair U and V of vertices, there is a directed graph or directed path from U and V and directed path from V and U. So from U and V and V and U, both, if they are both available, then we term this directed graph as strongly connected. Means if this is A, this is B, then if you have two arrows like this, then this is strongly connected directed graph. Path between nodes are extremely useful in various settings like road networks, computer networks, social networks, and various other possibilities are there. So this was the basic introduction about our graph theory, but we'll be talking about it more.